Exercise 14C, question number 1. The value of a car is modeled by the formula, this formula. Now, when you have this kind of a model, just study a little bit uh, this model, just to have a graph. So this is t, and the dependent value is v, and we see this is exponential part, and since this value is you can rewrite like 20,000 e minus 1 over 12 times t, so that value is negative. Then we are expecting a graph something like this. And now if you draw this one, see whether it's matched with the scenario. What is the scenario? The value of a car is modeled by a formula. So with the time value, its value is increasing or decreasing. Otherwise, it's not an antique car. It's normal car is decreasing. All right, it means it match with the curve. That idea is match with the curve. Now, when you look at this part now, this is like e minus x. What will happen? X goes to infinity, so y goes to 0. I discussed earlier this one, and x goes to negative infinity. We don't discuss here. Why? Because t can't be go to negative. So what is the maximum value of t then? Maximum value of t you can get when x equals 0. Sorry, t equals 0 in this one. T equals 0. When t equals 0, what is this value? So this is become 20,000 times e 12 0. So this is going to be 1. It means 20,000. So maximum value is 20,000. So I just look at what is going on this. I just study this formula. I didn't start the sum yet. So I get an idea and I just check whether my drawing is matched with the idea. Okay. Yes, car price is decreasing with the time. Now, what is the first question? State its value when new. Okay, we work out actually in when part A. The car is new when t equals 0. So it's 20,000. So we have to still calculate 20,000 e 0 over 12 in 20,000 times 1, that is 20,000. And part B, find is the value nearest to pound after 4 years, right? So after 4 years. And another important thing, we want to check whether the t is starting. The variation of this variation is v is varying 0 to, let's say, 20,000 to infinity. And t is varying 0 to, again, okay, let's say 10,000 to infinity. Now, this is the number line. So 0 mean in here what? New. So new to, in this one, old. Number line varying 0 to infinity, but the idea is new to old. Sometimes they will tell that, okay, year 1998 is the new to other years. Starting year is 998. So you want to say that the number line starting point for t is the idea. What is the actual idea in the real world? It is new to old, or it is talking about a year. When t equals 0 mean 1998 here. The dish is, if it is a dishes, this is a start. Or if they measure from this same sum from 1998 data. So after 4 years, so we can get when t equal 4, we had to put t equal 4. So v equal 20,000 e t is 4 over 12. So this is going to be 14,33063. So approximately 14331. The method is right. Part is sketch the graph V against T. So we have two sketch. One is this one, starting from 20,000, go to infinity, T, or this one. What is the difference of this one? So in here, it's the actual graph is going up to here, but do you think that car has a lifetime? I mean, after 10 years or 20 years, the car will break. And even if there is chance to go to T to infinity, no, it will stop. But at that day, uh, sometimes suddenly the value come to zero. Assume that engine failure, and it may come to zero. Question number 2. Population of a country is modeled by using this formula. P equal 20 plus 10 E T over 50. When I look at this one, this is not a exponential function. This is not, this is the exponential part. So, this is positive. So P equal 20 plus 10 E, I can write 1 over 50 times T. So the curve is going to be something like this. Is it match with the situation? How about the population with the time, increasing or decreasing? Yeah, it is increasing exponentially. So yeah, okay, it is matched with our thinking. Any exponential go through usually 0 1 point. Now we don't know it is 0 1 point or not, but so this is T and this is P, and at this point T equals 0. So when T equals 0, this part is become 1. 10 E 1 over 50 times 0, this part is 0. E0 is 1. So then 20 plus 10 times 1, which is 30. And also we can see that this is 20. It means I can write this one 10 E1 over 50 T times 20. So when you look at this part, we can see that there is a uh, luck, uh, translation to this graph. Then what is this? Asymptotic is at 20 because 0 whole system. So this is y equal t. Okay, this is t equal 20, and there is a gap between. So we are bring this one down, and when t equals 0, this value is 30. So this is going to be 0, 30, and yes, having this knowledge, we know that t goes to infinity The p also goes to infinity. So this is the idea. I just look at what is, I didn't read the sum even. I know population and the time. Yeah, with the time population is increasing. So the graph is matched with my thinking or my idea. Now p is moving from 0 to like this. Okay. T equals 0 mean, what is the real meaning of t equals 0? The P is the population in the thousand, I am reading the sum, and T is the time in years after 2000. It means when T equals 0 mean, in this sum they are referring this year is 2000. So this is the number line meaning T equals 0 and moving numbers. In literature meaning is here, the T equals 0 mean year 2000. Okay, what is the first question? State the population in year 2000. So when year 2000, now t equal 0. When year 2000, t equals 0, then we'll substitute here p 20, we work out t over 10, and 20 times e 0 over 10. I think there was this number here, 10. So 20 times 10 times 1. E to the 0 is 1. So this is 30. I think this is in thousands. In thousands. So P is 30 in thousands. Or you can write 30,000. Question number B. Use the model to predict the population in year 2030. It means when this means when t equal 30, because t equals 0 2000 and other t equal 30. So we can find 20 plus 10e t equal 30 over 10. So 20 plus 10e, this is going to be 3. This value also I also erroneously 50, 30 over 50. So that is 20 plus 10 e 3 over 5. So 38.221 in thousands, or 38. Part C is sketch the graph P against T for years 2000 to 2100. 2100. Uh, it means when T equal 100. So interval is 0 T equal 100. So I already did this one. So I just want to put this value is what? 100. T equal 100. So we'll write the value as well for the safe side. What is this value? When t equal 100, p equal 20 plus 10 times e 100 over 50. I put 20 plus 10 e square. So you will get a 93.891. So this is 93.891. Usually when they give an interval, we better find to the starting point 0 when t equals 0 and t equal 100. Now part D. Do you think that it would be a valid to use this model to predict the population in year 2500? So when we have this kind of sum, we have to first of all calculate 2500. First of all, we have to calculate the population. And then we want to think with the reality. So P equal 2 equal 10 when T equal 500. 2500 start in 20, so difference is 500. Yeah. When T equal 500, 10 times E 500 over 50. So 20 plus 10 times E, this is going to be 10. So what is this value? You will get this one, 220 284.657 in thousands. 220284, I will multiply by 1000. So basically 220 million approximately. When you look at t equals 0, 30,000 for and when t equal 500, t equal 500, so we are expecting 20 million. So this is not possible. Not possible. I mean, highly unlikely. So we can. It would not be a valid. Yeah, it would not be a valid model for higher T's as 220 million is a highly unlikely, that is probability word, quantity, there will be different factors. Who knows what will happen after 500 years? Different type of viruses, bacteria, reduce the population and natural disasters. So there will be different factors affect to the growth of population. So you have to match the person who made this sum, the idea, by looking at it. Question number 3. N equal 300 minus 100 E. I will write half a t, 0.5 t. This is the number of people infected with the disease is modeled by the formula. Now I am starting to study this one. So what is the exponential part? This is the exponential part. What is this value? 2.7171828. So if this is because of exponential, not because of because it follows the definition of exponential. Okay, I'll rewrite again. This is E. So I'll study E minus half a t. So I know ET. ET is this kind of. Then minus half a t. So Then E half a t. What is look like E half a t? E half a t also this kind of graph. Then minus E half a t. Then E minus half a t. E t, E half a t, E minus. So E minus half a t is going to be this kind of. Now 100 E minus 100 E minus half a t. So this is not negative. So it means it will something like this. So this is becomes 0, 100. And now minus 100 E minus half a t. It means it's going the opposite. All the values is going to be like this. So this is going to be minus 200, minus 0, minus 100 now because of this negative. Then so this is y equals 0 line. Then we want to add e minus half a t plus 300. It means we want to push this one by up 300. So minus 100 will come to 200. This line will at 300. So this is the asymptotic line. Now y equals 0 plus 300. So this is y equals 300, and this minus 0 minus 100 is minus 100 plus 300, 200. Something like this. Now I have to delete over because for t graph there is no negative. Time there is no time mean no negative, so it has to be like this. So this value is minus 100 plus 300, 200. So we are expecting this kind of graph for this one. So you should have this analyzing skills. I start with ET, E half a T, ET, E half a T, then I negative it, then multiply 100, then minus 100, and then add. You need to know the transformation step by step to get an idea or to sketch. Now, we need to know about T, more about the T. So with the number line, this is starting point is 0. So what is the literature meaning for this one? N is a number of people infected. Yes, that's fine. With the disease, and T is the time in years after detection. So this is just after detection. Assume doctors suddenly they found out oh there is such a virus. So at that time T equals 0. So that's the time. So they ask so question number A, when T equals 0. So I can see this is going to be 200 because when this is starting going to be 200, we have to show this one n equal 300 minus 10,000 e half a t. This part 300 minus 100 times e minus half a times 0. So this part become 1. So 300 times 100 times 1, 300 minus 100, that is 200 people will initially, so initially found out. Initially mean when t equals start of 0, that's starting point. 200 people were infected. Next question is, what is the long-term prediction of how this disease will spread? So then if there's a question like this that asking long-time prediction, it means they definitely ask what will happen when t goes to infinity and t goes to minus infinity. So in terms of x goes to infinity and x goes to minus infinity. But here we don't have time, we don't have a negative part. So what will happen, simply what will happen when t goes to infinity or t get higher value, what will happen to this number of infected people? So we want to know that the behavior of this e minus half a t. We discussed earlier previously, if it is et and e minus t, when t goes to or x goes to infinity, et goes to infinity. If t goes to infinity, if it is minus, uh, minus et goes to 0. So this will guide you. Then minus half a t also this kind of form. So when t goes to infinity, minus half a t goes to 0. Then this part is become 0. Then 100 times 0. 300 minus 100 times 0. 100 times 0 is 0. So answer is 300. So when t goes to infinity, the the curve go towards 300, and 300 is asymptote. It means more than 300. You can't see that the number of infected amount is more than 300. The maximum is 300. So you can write as t goes to mm, infinity, e minus half a t goes to 0. Then n equal 300, 100 times 0, which is 300, 0, 300. There's a different way of writing this. This is for the math student who write to plan to do maths in A levels university. Limits t tends to infinity, and I'm applying limit function 300 minus 100 e minus half a t. So this is going to be uh, limit t goes to 100 infinity, 300 minus limit t goes to infinity, 100 e minus half a t. So this is going to be 300 because there is no effect of t. So this part is going to be um 0 as et goes to 0. So this is 300. If you want, I can write one more step. So 100 limit t goes to infinity, e minus half a t. So 300 minus 100 times this part is 0. So 300 minus 0. This is very beautiful when they write like this. But that's fine. This is just for you, just to see this presentation. This is part C, the prediction. We have to do the sketch. So just write the equation, then we done. 300 minus 100e minus half a t. Question number 4. This is the formula. This is the exponential part. This is about the number of rabbits R, and M is the month modeled by a formula. So this is EM is this kind of one. E 0.2 M is Yeah, it's bit less gradient, same shape, and then this is 12 times. So it means it will stretch 12 times 0.2 m. So it's going to be something like this. Now this is 0, 1. This is also 0, 1. This is 0, 12. So the graph is we are expecting month. There is no negative months from here. This kind of graph. This is month, and this is PR and the population, and this is 0, 12 when m equals 0. Now we want to find the population. So what is this m? M is after m month. So it means at when m equals 0 after no month. So initially this is 0, 12. So the starting point, there were 12 rabbits in the cage, and then from that time onward is measuring. So after 1 month, then uh, when m equal 1, so r equal 12 times e 0.2 times 1. So 12 e 0.2, that is 14.65 approximately. It means 15 rabbits. And part B, I think after 1 year. 1 year means 12 months. Yeah, this is after, not when, after 1 month. After 12 months, 1 year means. So m equal 12. So r equal 12 e 0 point times 12. 12 is 2.4. So this is going to be 132.27. So approximately 132 rabbits. Part B, in the question they ask, interpret the meaning of the constant 12 in this model. Constant 12 means the initial rabbits, number of rabbit at the starting point. Initially, initially mean when m equals 0, there were 12 rabbits on the cage of population. Actually, we have to show this one. When m equals 0, before write this one, it will come here. R equal 12 times E 0 point times, so which is 12 times 10 is 12. Then you have to write the conclusion, because we wrote because we can see, but we have to give the calculation. Part C, show that after 6 months, the rabbit population is increased by almost 8 rabbits per month. 8 rabbits per month. Or if you say with the speed and the distance, 12 kilometer per hour. So they are talking about here rate. So 8 rabbit per month rate. So in mathematics, so rate is where you can see in the graph, it is gradient. or gradient we can come as dy by dx. In here it is going to be dr over dm. So I'm going to differentiate this one. So dr over dm equal d over dm 12 is 0 point m. So the answer is 12 times 0 0.2 times a 0 0.2 m. It means 2.4 is 0 0.2 m. So this is the gradient of this curve any point. I want to find when m equals 6. This is the tangent line. So we don't need the tangent line. I want to find the gradient of this point. So then dr over dm when m equals 6. So 2.5 is 0 0.2 times 6, which is 2.4 times e 1.2. So this answer is going to be 7.968 approximately. It means approximately 8 rabbits. Part D, suggest one reason why this model will stop giving a valid result for large enough value t. So they assume that this model is made today, then for other 50 years time this model may not valid because all the external factors may change. So we can give one reason, maybe a lack of foods or the food supply chain or the space or any other factors, temperature, okay, global temperature which is not uh, directly affected. So but yeah, especially the food and the space we can talk about, because when t goes to infinity, this is going to infinite number. So it's not practical for when t goes to infinity or large numbers. So simply we have to tell that for higher t's the t may not valid for higher t's as external factors may change, such as food and space. Um, the model may not valid higher m as external factor may change for higher m's. Model may not valid for higher m as external factor uh, may change such as food and space. Um, yeah, forest, etc. Question number 5. On Earth, the atmospheric pressure P in bars can be modeled approximately. So this is a graph with H and P, something like this. Use this. So there's no T, so it has to be, there's no H, negative H. Use to estimate the pressure of top of mountain range, which has the altitude of this one. So the question number A is, when this is pressure and the height. Height is measured with the kilometers. When H equal 34394. So simply we can apply P equal 0.313 times 4394. So this is going to be approximately 0.565 bars. Part B is I need to differentiate this one in terms of h. So dp over dh equal 0.013 times e 0.13 h. So this is minus 0.13 and this is again p. So So dp over dh. So this is key p, so key equal negative 0.13. So part C, interpret the significance of the sign of k in part B. So yeah, so the sign is negative. It means uh, it has a inversely proportional relationship. It means one is increasing, other one is decreasing. P is decreasing when H is going high, or P is going high when H is going down. So we can write that one. Part C, pressure decreases. Pressure decreases exponentially. So the exponential have that of a relationship. One is going, another one is increasing. Two factors exponentially as the height decreases, height increases. Part D, this model predicts that the atmospheric pressure will change by S% for every kilometer gain in height. Calculate the value of S. The model predicted that the atmospheric pressure will change by S. Uh, the discussion is so we have to consider two places as you will consider when h equals 0 and h equal 1. So now this is different is 1. So we want to find the rate of change here, and we want to find the rate of change here, and we want to get the rate difference with this with for a kilometer, and we want to express as a percentage. So rate difference with the initial rate plus rate multiplied by 100. So we find the rate here. The rate is dp over general, so minus 0.13 times E minus 0.13 H. When H equals 0, dP over dH, when H equals 0, this is going to be 0.31 times. This value is become 1, so 0.13. And when dP over dH, when H equal 1, 0.13 times E minus 0.13 times 1. So you will get a value minus 0.1141 approximately. Now the rate difference minus 0.1141 minus the first rate 0.13 and divide by the first rate 0.13 and multiply by 100. So this is going to be 12.0.12.0.1223 times 100, that is minus 12.23. So as a percentages, it is approximately 12%. Negative show the decrease, the direction. So the magnitude value of this one is 12. Question number 6. Nigel has bought a tractor for 20,000. He wants to model the depreciation of the value of his tractor T in T years. His friend suggests two models. So one is T time. This is the depreciation T. Use most model to predict the value of the tractor after 1 year. Compare your results. So let's when T equal 1. So this is, I will put 1 and 2 to identify easy. T1. So 20,000 times is 0.24 times 0. So this part is going to be 1. T1 is, okay, so this is 1. It's not 0. So 20,000 times this one, we will get answer 15,732, 33 approximately. And for this value, for this model, when t equal 1, t2 equal 19,000 times e 0.225 times 1. So this is going to be 15,723. Sorry, yeah, it is 15,723. So if I comment on this one, T2 for lower T, so I mean not lower T, for T1, when T equal 1, both model is, the difference is 10 pound. So it is, for T equal 1, it is fine basically. Not, it's a good model for T equal 1, but I don't know it is a good model for T equal 5 or 10, but when T equal 1, it's good because only just a 10 pound difference. Part B, we want to calculate now when T equal 10. Use model to predict the value after 10 years. Compare your result. T equal 10. So this is going to be 10 and this is going to be 10 and this is going to be 10. So then, so those are the approximated value 101814 and 2484. So model 2 predict quite large value. So however, we don't know which one is right. So just by looking at the number, we can tell that this is pound sign. So you can tell that large value is predicted by model 2 and difference is approximately about 670. 2484181, I think, yeah, 607. Part C, we want to sketch this one. So ET is 0.240, E minus 0.240, then 20,000, E minus 0.240. This is the breakdown going like this. Again, much not it's the same, and then it is the opposite side now, and 20,000. So it's going about 20,000, 20,000, and the asymptotic is still t equals 0. Now this one still the same. After this step, we have to shift this one. Same. Then we end up with this is 19,000, and I want to shift this everything by one unit. It means this is become the asymptotic become now 1,000, because bring up by 1,000, and this 19,000 become 20,000. 20,000. So this is the plan. Now we'll draw this one. So this is the £1,000 one. We need to find when t equals 0, because the starting point when t equals 0, this is become 1. So t1 equal 20,000, and when t equals 0, this is going to be 19,000 plus 1,000. Still 20,000. It means the both graphs starting from the same place. So this is going to be the first one. This graph is going like this, and this one starting from the same place and going like this. So this is T, and this is capital T. So this is model 1, and this is model 2. Last one, interpret the meaning of the 1,000 in model 2. So this is 1,000, and suggest why this might make the model 2 more realistic. So then the question is, if the question is asked like that, so we have to answer the question into more realistic way. Why it is? It means when t goes to infinity, or let's say when the tractor broke down or no more in operation, uh, and why it still the tractor has a value of thousand £1,000, because the only thing is the metal value. When the tractor is in the scrap condition, still there is a value. That the value is because of the metal. So so that is the realistic about. Metal has a minimum value of 1,000. This is the value of metal at a scrap condition.